So what they're asking us to do on this page is to see, hey Joshua, thank you, my dear. And then Fatih, I'll grab you some squares. We're looking at this pattern here, and we're just looking at the pattern of the outside border. We're just looking at these little squares, and it's page 19. So we're not looking at the inside, but we are looking at this outside and how many tiles it takes to go from one pattern to the next. So it's starting with 4 tiles across, and then he goes around the outside. My stylus disappeared, and I love that for me. That's so much fun. There it is. So one thing we can do is we can count how many tiles are in this border. How many tiles do we have out here? How many beige tiles or gray tiles do you have on this first figure on border 1?
4.
That's how many are in the middle. So there's 4 tiles here. How many are here? Just on this beige part. 10. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that made this shape. When we look at border 2, what has changed between this one and this one? How many more tiles do you need to make that new border? So switch this, the one you have, to look like this. Don't add more on the outside, just make this new shape. Kind of expand outwards, this piece, and see how many more tiles you need to make border 2. Again, we're not looking at the middle, just the outside. In fact, if it helps, I'm going to color these guys in white so we don't see the little lines. So I don't care how many tiles are inside. I'm just looking at that border. How many tiles are on the outside here? How many more tiles do you need to make border 2? You see, yeah, we just need to put one here, and one here, one here, and one here, right? So how many more tiles did it take? 4. For a total of 14 tiles. Ooh. We added 4 tiles. How many more to make border 3? Do the same thing, kind of work your way out. I made those guys. How many more tiles do we need? We need 4 more. If I scoot this out and put 4 more tiles in, I can make that new shape. So we've got to be really careful where we're looking, but it's all about finding the shape and finding what's changing. Because here we have 18 tiles in border 3. what this tells me is that whatever's happening to the other numbers, it's going to multiply by 4. Whatever my border is, times by 4. Each time. Border 1 multiplied, or we added 4, we added 4, we added 4. That becomes your slope. So figuring out the rest of it is a little tricky and is one of those things that takes practice. But finding how it's changing gives you what it's multiplying by. The way you can figure out the other pieces, if you are a mathy person and you like to work from X, Y tables, you can do it here. Border 1 gave us 10. Border 2 gave us 14. And what you're doing is you're finding the equation from this. You don't have to. We can find it other ways. But that's one option. I want to find a way to write an equation that uses this number somehow times by 4 to give me that 10. We're looking for a pattern here. There wasn't a question. I'm just saying we're looking at the patterns here. We're going to see if we can come up with something. They give us an idea on the page. We've got that Fred writes his expression like this. He takes the border number, takes away 1, times it by 4, and adds 10. What we can do to see if Fred's right is we can check it. We can test it, see if that works. We can say, all right, let's test Fred. If we have 4, looking at 1, minus 1, plus 10, do we get 10? Well, what we get is 4 times 0 plus 10, which is 10. So it does work for figure 1. 4 times, let's see if it works for figure 2. Minus 1 plus 10. So we get 4 times 1. Plus 10 equals 4 plus 10, which gives us 14, which does work. So this does work. It's a really weird way to think about it, because what he's saying is he's taking this border number, taking away 1 and multiplying it by 4 for some reason, and adding these 10 tiles on the outside. Not entirely sure how he gets there, but it does work. What we're looking at is we're looking at a way to write this pattern. What we have are the pieces that don't change for us were these ones here. Remember our pattern that we made with our little bricks? Those 4 pieces never changed. We added these 4 pieces in each time. Remember, that was figure 2. We added these 4 pieces in. That gave us figure 1. These 4 pieces that were on our side and these 4 pieces that were on our side plus these 2 end units never changed. So these 10 tiles never changed. That's where he got that 10 from. So we're trying to find pieces. And if we look at the pieces that change, these 4 are where we're getting that from. Trying to find patterns in here. Okay? The 4 that's on the outside are these 4 pieces. Those 4 pieces are these 4 pieces. These were the new pieces here. These 4, and this one never changed. They were still there. That's this one, and this one. So if we wanted to write our pattern, we could do 10 plus the 4. We could take our 10 here plus 4 to give us B. Plus another 4 to give us that. If we wanted another one, we could add another 4. So what we're doing is we're taking 4 times our border number to figure out what we've added to that 10. So 4 times our border number plus whatever the heck we start with. So you got to figure out what we start with and add in what's changing. So if we could go back and figure out what started, we could find more. We could keep going times 4 plus 4 plus 4 each time. We could find as many as we wanted. It's going to be easiest if we can write patterns. We know 4 times that border number gives us what we've added. Let me see that part, at least the 4 times the border number. 4 times this number down here. This number down here. This number here. The easiest way to figure out an equation, because we are going to want to be able to write equations here, is to take our pieces and kind of plug them in. We want 4 times figure 2. So if we look at 2, we can pick whichever one we want. We can do 2, we can do 3, whatever. 4 times figure 2 plus something should equal 14. Four times whatever figure 1 is plus that same thing should equal 10. Can we figure out what that is? Or same thing for 4 times figure 3 plus the same thing should equal 18. What should go in that blank? 4 plus what gives us 10? 6. 4 times 2, which gives us 8, plus what gives us 14? 6. 4 times 3, which is 12, plus what gives us 18? 6. So what this tells us is if we want to write this as an expression, we can do 4n plus 6. Will tell us exactly how many tiles are in our border. 4 times whatever our number is. So we find our pattern, we find our values, and we can use that number to spit it out. That's the easy way to do it. Fred went a really weird way. we can always test somebody's stuff easier than it is to find our own pattern. So we can test a pattern easier than it is to find our own. But being able to find our own pattern here is going to be one of those things we're looking for.
Where'd you get 6 from?
We looked in here. I took my, I know it's going to be times 4 because we added 4 at the bottom. So whatever we're plussing across is going to be what it's times. 4 times my figure 1 had 10 tiles because figure 1 had 10 tiles. 4 times 2 plus something gives me 14. My 2 came from here. My 14 is right here because this had 14 tiles. I feel like I did this in a very scrambled order today. Figure 3, which is this one, had 18 tiles. We counted that here. And what we did is we know that 4 times 1 plus whatever is going to give me 10. 4 times 2 plus whatever gives me 14. 4 times 3 plus whatever gives me 18. So we notice that all 3 of those is 6. That's where the 6 came from. Okay? So part of what we're going to be doing is trying to find those patterns. And sometimes we're going to have to check somebody else's work. Like Fred. Fred went real hard on it. If Fred's way makes sense to you, great. There are quite literally an infinite number of ways to write expressions for these patterns. I feel like this is a fairly straightforward way. But if your brain works different ways, where we look at what's changing between them, we look at how it's changing. It's changing. This one added 4. This one added 4. Which means we're going to have 4 times this. Okay, so these patterns are weird, but that's going to be a big part of this, is noticing those patterns. So we're going to take a switch to page 18 real quick, and then we can come back and look at those last 2 at the end if we have time. But I want us to look at page 18, because what we're going to do is we're going to see if these pieces are equivalent. So what that means, are they equal? Equivalent means equal. Are these the same? And we're going to start with trying to do it without plugging in numbers. And this is one of those, if we need to plug it in to test, plug it in and test. Anything but 0, 1, and 2. But we hopefully can look at them and see. Is A plus 3 minus B the same thing as A plus 3 minus B? Does it matter what order we add stuff in? Not really. 2 plus 3 minus 4 is the same thing as 2 plus 3 minus 4. It doesn't matter. So let's do 4 plus, I'll do 3 and 5. It doesn't matter which way we go. We're still going to wind up with 4 minus 2, which is 2. 7 minus 5 is 2. Adding and subtracting it doesn't matter the order. If there's a way that makes it easier for your brain, do that. This gave us -2, just to clear up. -2 plus 4. This gave us 7 minus 5. Same thing. You can test this by plugging in numbers. That's fine. But adding and subtracting, yeah, they're the same thing. What about this second one? 2 plus k over 5 and 10 plus k. Are those the same? What if I plug in 5 for K? Will I get the same thing? 2 plus 5 over 5. What's 5 over 5? Yeah, it's just 1. So 2 plus 1 is 3, right? 10 plus 5, that's 15. These do not equal each other. They're trying to trick you in the fact that if we were working on other sides of an equal sign, you could multiply both sides by 5 and like get a thing that looks really similar. But we're not on an equal sign here. These are not the same expressions.
Where'd you get the 5 from?
I made it up. I was picking a value to test. That's why I put it in a different color. I will make it a brighter color. So this 5, I substituted in for K. I picked a number. I picked it because it was the denominator and I knew that would simplify to a number we could do in our head. But I made it up to test it. Same thing up here. I made up the 4 and the 5. It's the same 4 and 5. I made it up because I'm just testing. So this is a test. Say it again. We're almost done here. I've got 2 more of these that I want to go through. Now, this one's a little bit harder. A minus b squared and a squared minus b squared. Are those the same? No. If you remember your algebra 2, oh snap. This is a difference of squares. This is a perfect square. If I factored this, we could get a minus b, a plus b, which is close to a minus b, a minus b. They're close, but they are not the same. You can test this. Make up numbers. 7, I don't know. Somebody give me a number. 4. 7 minus 4 squared. So 7 minus 4 gives us 3. 3 squared is 9. Then if we fill in over here, 7 squared minus 4 squared, that's 49 minus 16. It's 33. 9 is not the same thing as 33. So you don't have to remember the factoring stuff. You can test things to see if they're equivalent. You don't have to give up if we don't remember factoring stuff. Because it's been a minute. We aren't always going to have to, but it's fine to test stuff. Let's look at this last one here, and then I'll stop griping at you. Are these 2 equivalent? Are they the same thing? Yeah. What did they do to get from here to here? Distribute. And that's something we can totally do. They took the 3 times the z times the w. 3z, 3w. Yes, this one is equivalent. They mean the same thing. That is a valid move you can make on an expression. I cannot willy-nilly multiply or divide them by stuff. So there are more on this page for you to practice. And in fact, several of them, I believe, show up in the homework. Homework 2 is all about patterns and are they equivalent or not. So using what we did today, homework 2, it's on Canvas. Okay, on the Canvas assignments. You can do them as many times as you want to. I think it is currently limited to 3. but I can always add more. What's up?
I have a question about the last homework.
Uh-huh.
What's it called? Chocolate.
The chocolate math.
For that second question, you just want us to.
So the number you would have put in for pieces of chocolate,
Yeah.
put like X or something. How would it work in general? So you're putting in a variable, because I believe it's what it says, is to put in a variable. So pull it up, yeah, and we can talk through it. Absolutely fine. Okay, we are going to have a chapter test on the 25th, which is next Friday. I will get you a review for it. I'll probably give you the review next week, so we'll have 2 days to review. We have a couple more activities to go on this. The making models is one of those, or the making equations for patterns is one of those things that we're going to need to be able to do. Okay, so we're going to practice that some more. We've got a few more things to do. If you had one of the sets of tiles, I like your little tower, it's fun. If you had a full set of tiles, please put the tiles back in your bag. A couple people had just loose tiles, and I will come grab those. Okay, so work on stuff. Practice these homework assignments, okay? I do not assign them to you for fun.